Thank you, David, for the introduction, and thank you all for coming. It's really great to be in Vienna and at the Complexity Science Hub. My name is Iyad Rahwan, and I run a group at the MIT Media Lab called the Scalable Cooperation Group. Now, I want to kind of put this idea of machine behavior in a broader context and talk about a couple of projects that are ongoing at my group. But first, I wanted to start by talking about, what I think is the originator of this idea is Herbert Simon, who was not only a Nobel Prize-winning economist, but also won the top awards in computer science and in psychology. So he's like a true multidisciplinary scientist in every sense of the word. And Herb Simon wrote this very intriguing book called The Sciences of the Artificial. And in this book, he contrasted this idea of natural science, which is the study of the natural world, with artificial science, which is the study of artificial objects and institutions. So, for Simon, it was artificial things are not just physical things like robots, but they're also institutions like markets or legal systems that we design. And he was promoting this idea that was very new at the time, which is that we should study these things scientifically with a scientific method, just like we study natural objects and phenomena. And I think today we have very much artificial institutions, not just bureaucracies with rules and kind of a life of their own, but also algorithm-augmented institutions. There are algorithmic decision-making systems that are helping decision makers make all kinds of decisions, from urban planning to more recently, who should be granted parole, or how much, whether a person should be able to go on bail or not. And also we have algorithmic actors in the environment. So that's the other thing. We have social media bots. We have bots trading, buying and selling on the stock market. In fact, the majority of stock market trades are now algorithmic. And it's really hard to even estimate, but there's a substantial amount of fake accounts or bot-operated accounts online. And soon this will only grow, right? So let's try and put this thing in context by just talking about AI as an abstract concept now. So I'm going to use this little robot to describe an AI system. This could be an autonomous car, or it could be an algorithm, running a hospital. It could be anything for that matter, or an algorithmic trading program. And I just want to talk first about why we care about the behavior of the AI or of the machine. And we care about it because we care about the behavior of actors like humans in the world, and we care about constraining those behaviors in some way. So this is a picture based on the book from Larry Lessig called "And Other Laws of Cyberspace." And in this book, Lessig really was promoting the idea that computer code is a force of regulation, right? That our behavior is regulated by 4 forces. These forces include the law, so the law clearly constrains our behavior, but the market also constrains our behavior. The architecture of the environment, the physical environment and the information environment constrains our behavior, but also social norms constrain our behavior. We care about what other people think and about what is the right thing to do and so on, because we care about what people think of us. And what's happening now is, instead of the human inside here, we've got some kind of AI system, right? And we want to think about how we can constrain the behavior of the system so that it's legal, it is socially desirable, it's in line with our norms, and so on. And you could think of the behavior, for example, of an autonomous car. You wanted to obey traffic laws, but you also wanted to perhaps obey some other norms, right, about how one should drive. Even if somebody was driving legally, they should not be driving aggressively, for instance. So these are all behavioral questions. They're not questions about how to engineer the car. They're questions about what the car does and whether what it does is in line with our expectations. They are questions about behavior. So there is this idea of human in the loop, that you observe the behavior of a machine, like let's say an autopilot flying a plane, and that you then can intervene and adjust the behavior if something goes wrong. So for example, if the autopilot flying the plane, there is always a human pilot in the cockpit, and the human pilot can always intervene and when the behavior is outside the expected. But there is a new problem, right? Which is the problem of disagreement about what the acceptable behavior is. So in many cases, in the case of the autopilot, you know, suppose this is the human pilot in the cockpit observing the AI system, and then these are, suppose, the passengers. Everybody wants to get from A to B safely. We all have the same goal. But suppose that we have a system that is implementing some trade-offs. And people disagree about what values are more important, what behavioral outcomes are more important. So some people care about fairness, other people care about efficiency, other people care about safety, and so on. Now, this brings a new question, which is, first, we have to decide what we want. So we have to negotiate our own values, which is something that we have to figure out as a society before we set the behavioral parameters for the algorithms themselves. So this is what I call the society in the loop problem. So it's the problem of deciding collectively what we want as simultaneously as we supervise a complex AI system. And this society in the loop is basically the human in the loop plus a mechanism for the social contract. So this is just to kind of set the context, but it requires us to understand the behavior of the machine, right, to begin with, to see if it's compliant. So I'm going to talk to you about two things now. One is one project in which we're trying to help promote this idea of studying machines behaviorally, and also some work that I'm doing on how can you facilitate the negotiation of the social contract. So let's start with machine behavior. Now, there are many AI systems are now today used for doing all kinds of things like music recommendation, navigation, getting a job. You know, there's algorithms that help sort CVs now and shortlist candidates for job interviews. Algorithmic trading and purchasing, medical advice, medical diagnosis is now algorithm augmented, and there are algorithms that are that exceed human performance. But also there are autonomous cars that need to make decisions about how to drive in normal situations and also in critical situations. Now, I want to give you examples of the kinds of questions we might ask that are behavioral, that are not engineering related. For example, in the case of autonomous vehicles, how aggressive is this particular car overtaking behavior compared to other cars, right? Or how does the car distribute risk between different stakeholders on the road? Is this car behaving in a way that endangers pedestrians more, or cyclists, or people in the car? And how does it distribute the risk between all of those players? An autonomous weapon, you may ask, without knowing anything about how it's implemented, is it respecting, for example, the laws of war, right? Which is something that we hold human soldiers accountable to. Use of proportional force and things like that. And for example, does the weapon distinguish between combatants and civilians? And of course, we can ask whether we should allow autonomous weapons altogether. In the case of algorithmic trading, we know how to, identify collusion between humans. But, what's collusion between trading algorithms? And what if it happens without explicit communication, without intent? Does this count as collusion or market manipulation? And in the case of algorithmic pricing, algorithms that determine the price of products and services, are the algorithms engaging in fixed pricing of some sort? And are they doing price discrimination? Are they asking you to pay more just because they know you have more money, right? Newsfeed algorithms that decide what information you see in your newsfeed. Are they creating filter bubbles? Are they disproportionately censoring some content versus another? Some people think that Facebook, for example, disproportionately censors conservative content rather than liberal or content, and algorithmic sentencing, and so on. So online dating, conversational robots, you can imagine, you can see there are lots of questions that are behavioral that can be studied by a psychologist if they could just have access, if we could just make the job easier for them. You don't need to be a computer scientist to ask these questions, because social scientists, behavioral scientists ask these kinds of questions from humans. And we think there is a gap, we're calling it the AI knowledge gap, which is a gap between the number of AI agents that are being deployed in the world and the number of studies of the behavior of those agents. So we are more quickly deploying systems than understanding their behavior necessarily. So to close this gap, we want to promote this idea of behaviorism of machines. And we wanted to start with the behaviorism of that progressed animal behavior study, the science of animal behavior in the 20th century, which really started with a simple mouse. And the idea is to see an algorithm or an AI system as a kind of organism. And you don't just study it by looking at it and its source code, because the source code, as David has mentioned, doesn't always tell you about how the system is going to behave once you switch it on and it interacts with the environment. Instead, what the behaviorists did is they said, well, I want to be precise about how I describe the behavior of this organism, and I'm going to have a stimulus and a behavioral measurement, and I'm going to manipulate the stimulus, and I'm going to measure something precisely so I can make very clear inferences about the nature of this behavior and what causes it. So for example, you could alter the temperature, and then you can measure the amount of sleep, for instance, as an outcome variable of interest. So what we want to do is something, we're promoting this project, which is an ongoing project in the lab, called the Turing box, which is play on the Turing test and the Skinner box, where you would also take an algorithm and subject it to stimulus and response. You don't have to understand how it's implemented, but this would allow you to test hypotheses about how it behaves. Now, we would start here, but simultaneously, it's also important to study algorithms in the wild, which is something that other people are doing and we're doing as well. But I think it's important to also start with the simplest situations, the simplest cases like this. So the idea is to use a black box paradigm. You control exactly what the input is to the algorithm. You use the algorithm just as a function, and you apply some kind of metric to it. And then finally, you improve the stimulus because you're now testing new hypotheses. So you're constantly revising your hypothesis and developing new metrics, but also improving algorithms. So different people computer scientists would come up with their algorithms. And we want to study them by subjecting them to different criteria, different behavioral metrics, right? And if this metric is this algorithm fair, or is this algorithm legal? Then maybe we'll have very precise thresholds by which we hold these algorithms accountable. So at the moment, we're building basically an online platform that is a market that would match two kinds of players that don't really talk much to each other today. The contributors are people like who build AI algorithms. They're computer scientists, roboticists, machine learning experts. They're interested in benchmarking their systems, and they're interested in solving the reproducibility crisis in AI. They want to make it easier for other people to use their code and also to characterize and compare their system to others. And then on the other hand, you have the examiners. These are the scientists of behavior, they could be social scientists, but they can also be computer scientists. And they would like to study if certain algorithms are biased, certain algorithms are fair, and so on. And what we would like to do is create a platform where we match those two parties together. We want to make it easier for the examiners to examine the algorithms without having to be technical computer scientists themselves. And we want to make it easy for computer scientists to evaluate their systems through a variety of lenses. Now, that's kind of what we're doing at the moment to advance this idea of a behavioral perspective on understanding machines. Now, let me talk about how we understand or formulate what behavior is acceptable in the first place. especially in contested domains, right? In a domain where people strongly disagree on what matters the most. And I found the case of autonomous vehicles to be a fascinating one, because it's going to be one of the first mass-produced AI technology that can literally make life and death decisions. Because once cars are on the road, an AI controlling a 1 or 2 ton vehicle is going to hit something at some point, right? And compared to today's situation with 1.2 million car auto crash fatalities around the world, a lot of estimates expect that the vast majority of these accidents are caused by human error, the inability of humans to react fast, or to maybe they're sleeping at the wheel, or maybe they're drinking and driving, and so on. So in principle, we can improve the situation dramatically. However, people are concerned about giving the machine the power to make a moral decision about how to distribute harm, the risk of harm. And this so-called trolley problem has really captured the public's imagination when they think about these questions. So imagine a car that is an autonomous car that is driving at the legal speed limit, but all of a sudden, some people jump in front of the car. And the car can either run them over, or it can swerve and kill a bystander, but only one person. Should the car do this? This is an old philosophical riddle from the 70s, actually, that people thought was completely hypothetical until autonomous cars came. And then the new question is, well, what if the person being sacrificed in this case is the person in the car? Which kind of brings a new dimension to it, right? So we ran a study that was published a couple of years ago, and this is what we found. People say, well, I would never buy a self-sacrificing car, but I want everybody else to buy such cars. So people say, if you ask them, what do you think the car should do? They say the car should definitely minimize harm. Would you buy this car? Absolutely not. And I think that says something about our inability to negotiate this social contract. And in fact, when we told people, what if we force all the cars to minimize harm, so that you're not the only person, risking yourself? People will say, well, I would rather keep my own car, right? So people are not willing to transition to the new technology, and which is a bit of a problem. Even if the technology is safer, by the way, which is some of the follow-up research we've been doing. So, so we wanted to engage the public on a broader scale with these sorts of questions. We created a website called Moral Machine, which you can visit yourself. It's translated to 10 different languages, including German. And we wanted to really engage the public with this topic and collect a little bit of data. We did not expect it to be extremely popular, but luckily our expectations were exceeded. The website looks something like this. So it's a multifactorial design. So there are 26 million possible comparisons that can be made through this very simple cartoonish depiction of an accident. And we vary all kinds of things like the species. Sometimes it's animals being sacrificed, sometimes it's humans, sometimes it's young people versus old people, men and women. Sometimes it's homeless people versus business executives or doctors. So because we want to understand if people care, think your value as a human being should matter, right? And so on. And sometimes people are crossing illegally, like a red light. Should this be taken into account? Now, to our luck, this research has been covered by some of the major mass media, but also a lot of the new media. So a lot of YouTubers with 50 million followers who play games, and other people watch them play games, have also started playing this Moral Machine and doing our walkthroughs and talking through their decisions. What happened is, as a result, is we have more than 4 million people contributed 40 million decisions, and over 500,000 surveys or demographic surveys that were optional were also filled. So it kind of inadvertently became the largest, what I think is the largest social psychology, like moral psychology study ever conducted, and with fairly global coverage. Now, I would love to talk about the results, but the results, the paper has just been accepted in a journal, and the journal has an embargo policy, so the results will come out in a couple of months, hopefully. But I just thought I'd give you a couple of examples of mini results by taking some votes here today that will highlight to you how tricky these questions can quickly be, even though we're using a very simplified scenario. So the question here is, there are two people in the car. The car is going to hit a barrier and kill them, but the car can swerve and kill two people crossing the street. You're an external observer. The programmers are asking you for your opinion. How do you think we should program the car to behave in this situation? How many people would say keep going straight? Can you vote? How many people say swerve? Okay, more people would say go straight. So, in fact, indeed, this is what we found in our result. Kind of easy, right? Now let's do this. If the car goes straight, now the car, as you notice, is empty. It dropped somebody at work, and now it's going to park itself, and it found itself in this situation. But the car is going to kill a child if it keeps going forward, or it can swerve and kill an adult. And let's assume that these are the only two possibilities. How many people would like the car to go straight? Swerve? Okay. So there's clearly an action bias, even, so some people would say, I would rather not intervene, and if the child goes, that's their fate. And indeed, we find most people swerve. Okay, now let's do slightly more complex scenario. If the car goes straight, it will kill a person crossing legally, or it can swerve and kill the person crossing illegally. How many people would go straight? Swerve? We are in Western Europe. Yeah. In fact, yeah, this is something that the paper will explore a little bit more, how cross-cultural differences can explain some of the things that we've observed, and that we do find that the propensity to punish the person who is crossing illegally does change by culture, by country, and you can imagine which countries would be more likely to swerve. Now, finally, what if you had two people crossing illegally? How many people would still swerve? Okay, see, so the rule is not absolute, right? And this is indeed, in our samples, fewer people would start swerving, would say swerve in this case. And so it clearly gets very complicated very quickly. Now, in real life, the situation is not going to look like this. The situation is going to be much more benign. It's going to be a car is in the lane, and a truck goes, is on your side, a very large truck. Where do you position yourself in the lane? Do you stay, or do you slightly move to the left? There's a cycling lane on your left. Now, if you always choose to move a little bit to the left, and you have, this is the software, and this software controls 1 million cars, eventually, most of the cases, no dilemma, nothing will happen, but eventually, some cyclists will die if you're moving closer to the cycling lane. And if you choose to stay, eventually some passengers will die, right? This is a similar kind of trade-off. It's not iconic like this. It's not like one given situation in a moral dilemma, but it's a dilemma still of the same kind, because you're making a choice about how the car behaves, and then eventually you will see some risk distribution, or distribution of harm. So hence the importance of understanding behavior rather than just focusing on the engineering. Thank you very much.
Thank you very much for the interesting talk. If I actually jump to your very last point, the bike lane example, do you think that the algorithms that are being developed and programmed now actually capture the full idiosyncratic range of decisions that are being made in an autonomous vehicle versus a human driver context? As somebody who's been building these algorithms for a long time, I have a bias right now, which is that these algorithms are nowhere near ready for deployment. So the third choice here is, we're not ready for it because there is no moral consequence for the autonomous vehicle that gets involved in a crash. So
yeah, it's a very good question. I think that I think we don't really know. So I think I haven't done the studies myself. I've spoken to some people from the Rand Corporation who've been doing some studies trying to estimate. Well, they're asking the question is, how do we know if autonomous cars are actually safer? Like when they cross the barrier of becoming safer than the average driver, this question is not easy to answer, apparently, because the way that you measure the performance of safety, you need to sample the driving conditions from a sample that is representative of driving conditions that people encounter. And at the moment, most of the testing happens in southern states where there's a lot of sun and clear skies and no fog and so on. So I think we're unable to answer a lot of these questions, but maybe you have some intuition. A lot of engineers seem to have an intuition that this will be ready in 2 years, right? It's just a matter of perfecting some things, and these are all edge cases where you've got some funny looking road sign, and we can handle those. I don't personally work on building autonomous cars, although a lot of the colleagues at MIT do, and they seem quite optimistic, and a lot of their investors are optimistic. They're putting billions of dollars into this software. For me, the question, I'm agnostic about when this will happen. I do think that as soon as they're safer, and that we know with a certain degree of confidence that they're safer, we should have them on the road, because that's actual lives saved. But when we do so, it's no use if all of the people who die, let's say we reduce deaths by 50%, but everyone who dies is a cyclist, or everyone who dies is a child. There has to be some proportional improvement of some sort, and it has to be, the public needs to be informed, have some sort of consent to this transition. And in some cases, we have no choice because they will be consumers. And what our first study showed is that consumers will prioritize themselves, and they may actually slow the adoption because they over-prioritize their own safety. They may overinflate the risks. So I'm interested in the psychological effects, but I'm agnostic about the kind of the technical development and the speed of that.
Coming back to your Turing example, in BIM, building integrated models, that is one of our major questions. How do we, not who we are or what we are, but how we influence others, how they are seen. It's no matter if that is a machine which is answering or human, the artificial intelligence, but how it can influence behavior of the participants in the project. And you can replace your examples of fairness, security, and whatever by time, cost, and quality when you set up wellness. Yes. So that's major questions in BIM models. Has there been done any studies on that field? Because I really searched the net on complexity projects, and there was practically none on building.
Yeah, I would say that the discussion of AI kind of today is dominated by the ethics question. So there's this idea that we need to make machines ethical, and we have to decide which ethical theories to use, whether it's consequentialism or deontology or something like that, and how to implement these in a machine. And I think these are I think it's a useful question, but I think it's the wrong question. I think the right question is, how do you resolve conflicts between different optimization objectives? Something that we do all the time when we decide which medical research to fund, or where to put a hospital, or where to build the schools, right? Or what speed limit is, where to put speed bumps, because they will slow down somebody from getting to work, but they will increase safety for some people. We can eliminate accidents by making speed limit 10 kilometers an hour everywhere, but that would be a loss of economic productivity that we as a society are not willing to take. And these things change over time. So I think the right discussion is a public discussion about trade-offs, social contract, the construction of this social contract that is mediated by algorithms. And I think it is kind of missing because there is this idealization that we can endow the machine with ethical compass, and then all the problems will be solved. I think instead we should just use the regulatory tools and the ability of, evaluating like qualia and things like that. How do you value life, and therefore do you decide where to invest the taxpayers' money? I think we have a lot of these institutions and ways of thinking about distribution of risk and harm and benefits that we can readily adapt to this new problem. But to do that, we need to understand how the machines behave, what they can and cannot do, which I think is also another missing piece of the puzzle.
Thanks. So it's really interesting. I was wondering if you included, because basically you assume now that you have, let's assume that we solve this problem of having a perfect contract, social contract and norms, etc. Now, we know as humans, we are sometimes opposed to each other. So for example, let's take an electronic billboard, and I run an ad on the electronic billboard, and I include some special pixels that your image recognition program in your car misunderstands, and I can trigger an accident. Let's call it a terrorist attack, yeah? So I think, are you also aware of research including the reaction of humans on these defined norms then? Should we include that as well?
We should. I mean, the truth is that these are going to be complex systems made up of humans and machines, which is why, so together with Ian Cousin here and Manuel Sabrian and others, we're trying to conceptualize this, like what are the main questions. And some of the questions are this feedback loop between human behavior and machine behavior at the collective level. And for that, I think you need a complex systems perspective, for sure. Thank you.